Ready. You
On
remembered.
top of my game today.
Yes, you are.
All right. So tomorrow's the big day,
It is.
and then that's it. All done.
Yep. Yep.
All right. Very good. Okay. So to be continued, right? Right.
Yes.
Okay. I think I put everything in Google Photos. I hope I did. Yes. Okay. Do you remember that? Okay, I can look at my. Just talking to myself. It's all right.
No worries. We're good. I
Folks,
do it too.
folks are folks are trying to figure it out, but they can't. So we did that one. Haha. All right. I actually clicked on the correct one right away. I just didn't trust myself because, why would I? Okay. So, I mean, we could totally graph it, right?
Mm-hmm.
But since it's a quadratic, meaning the greatest exponent is 2, then all we have to do is look at the sign of the coefficient. If it's positive,
Okay.
that means it's a happy parabola. If it's negative, that means it's a sad parabola. Yeah?
Yes.
Okay. So do you see how a happy parabola would have to have a minimum and a sad parabola would have to have a maximum?
Yes.
So since this is happy, it's has a minimum. Or you can just crank it in your calculator and look and see that it opens upwards, right?
Mm-hmm.
Okay. So find the minimum or maximum value and determine where it occurs. So if it's where it occurs is the value of x. The actual value, the minimum value is the y coordinate. So you're really looking for the ordered pair. Um,
Okay.
to do that, we did this yesterday. I think we did that, the x coordinate of the vertex, which is going to be the minimum or the maximum, it doesn't matter, right? Whether it's a
Mm-hmm.
happy or sad parabola, is equal to negative b over 2a. Did we do that?
Yes. And then you plug in and get the X and plug it back into the f of X.
Correct. Correct.
Mm-hmm.
So then this would be what? Negative 12 over 2 times 2,
Yes.
which would be 12 over 4, which is 3. So that's where it occurs, right?
Mm-hmm.
And then the actual value is when you plug it in. So it'd be 2 times 3 squared minus 12 times 3 minus 8, which is what, 18 minus 36 minus 8, which I think is negative 26.
Okay.
So that's where I would think the ordered pair would be fine, and that's the value.
Perfect.
But hopefully he would just take the ordered pair. Okay, so then the domain and range. First of all, do you recognize that as a parabola? Do you see a quadratic and go, yeah, that's a parabola?
Yes.
Okay. And are you able to see if it's happy or sad? Yeah, if you can graph,
Yes.
you can, right? So, I mean, you know that the very minimum is at 3, negative 26, right?
Mm-hmm.
So the domain, remember, or tell me generally what is the domain of a function? What are we talking?
Negative infinity to infinity.
It's the x values, and in this case, yes, negative infinity to infinity, right? The domain are all the possible x values.
Mm-hmm.
And so since this is opening from, going left and to the right, it's getting wider and wider and wider. It's going to take all the x values. The
Right.
range is all the y values.
Would it be negative 26 to infinity?
Yep,
Okay.
boom. Except negative 26 included.
Is a bracket? Okay.
Yeah, there we go. All right. Okay, so again, parabola, right?
Mm-hmm.
And it's sad. Any projectile is a sad parabola because the ball has to come down. Yes.
Yes.
Okay, so I think a sketch is in order. This sounded way too formal. Um, so it's thrown from a height of 5 feet, right? So,
Right.
well, I don't know, maybe we think of like some loser throwing a ball in the air. Yeah.
Mm-hmm.
Like your boy Nino. That's a good example because, loser, but I'm sure he can't throw. Um, so we know that this is 5 feet. Yeah. And so the path of the ball would be something like that. Yes.
Yes.
Okay. And so the max is going to be at the vertex. Yes.
Yes.
So again, off we go, right? X um, is going to be equal to negative b over 2a, which is equal to negative 1.4 over 2 times negative 0.2, which is negative 1.4 over negative 0.4. Why couldn't it be nice? Which is 3.5. Now that's not the max, that's the x coordinate where it occurs.
Yes.
Okay. And then so we got to plug that in. It's not looking for the coordinate. So negative 0.2 times 3.5 squared plus 1.4 times 3.5 plus 5. I got 7.45.
I did too.
Cool. So 7.45 feet.
Wait, I plugged in my calculator and I got 12.35.
Do you have a negative in front of the
Oh,
22?
forgot about that.
Don't do that.
Yup.
Oh, it says round to the nearest tenth. So that's 7.5, those dirty dogs. Although I don't think I'll care if you're not inputting it.
Hmm.
Um, I don't know if I like this at all. Let me see what question B is. There is no part B.
Yeah, you have to plug in the answer and then go to part B.
I see.
Yeah, but I'm good on this because I've done one of these before on the homeworks and I was good.
Okay, how did you find out how far it is from the release?
Um, well, I plugged it back in like this. I
Right.
think the maximum height was possibly the 7.5.
Yeah, the maximum height is 7.5. My question is,
Mm-hmm.
like, we have to find. Oh,
I think it would be 7.5 and then 3.5 for
well,
the
no,
answer.
because 3.5 is actually the distance from the ground. Like if the ball had started down here, that would be 3.5. Does that make sense?
Okay. Yeah.
Okay, so what we have to do, we know that here is 3.5, right? This is the
Mm-hmm.
point, 3.5, right?
Mm-hmm.
And then over here, I get to break Nino's leg. Awesome, is 0. So we have to find what corresponds to a height of 5 for a y coordinate of 5,
Okay.
5 feet high, which you can plug into your quadratic. I can't think of another way. I guess what we could do, here's what we could do. We could find this, since it's perfectly symmetrical. No, that's not going to help. Okay, here's what I would do. I would, if I find the value of x when y is 5, then I have the
Mm-hmm.
x coordinate. Does that make sense?
Yes.
And then I can take 3.5 minus that x coordinate. Are you
Okay.
okay? So
Yeah.
the way we do that is we let 5 equal the y, right? We replace this f of x with 5. So we're going to say 5 equals negative 0.2 x squared plus 1.4x plus 5. And then we subtract 5 from both sides to set it equal to 0.
Yes.
And then you can use your polynomial tool to solve it. You want to try that again?
On the calculator?
Yep.
Okay, yeah. I'll pull up the instructions in my notes. And the order would be 2.
Negative 0.2. Oh, I'm sorry. Yes. Oh my God. Yes. Ooh. Ooh. I don't care for this at all.
I got um a decimal point. I got -2.603, and then the second answer I got was 9.603.
It did say it was 5 feet off the ground, right?
Yeah,
So that would be time equals 0. Oh yeah, it would be 0. It is 3.5 feet, but that's a coincidence. Okay, so I think you did something wrong. Did you put in -0.2 for the A, 1.4 for the B, and then 0 for the C?
yeah,
Okay, because the solutions are 0 and 7. You want to double check that?
yeah. I'll plug it back in. Um, the order would be two, or would it be one?
It's 2 because it's the order is the greatest exponent.
Okay,
And
so
did you put in -0.2?
yeah, and then I did +1.4 +5.
Oh no, 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 no. It's 0 because we subtracted 5 from both sides.
So put a zero where the five is.
Yes. Do you see what
Okay.
I mean right here?
Oh, okay, okay.
Yeah.
Then I got 0 and 7 as the answers.
Good. Now 7 is on the other side, right?
Hmm.
So, but 0 is what this is, and this isn't 0, it's negative something. So the distance is 3.5.
Okay.
Why would that? That's a coincidence that it's the same as the x coordinate.
Agree.
Okay. It's not always, it wouldn't always be that. So, okay. So, um, you could graph this, but it would be tough to get it right unless you knew a bit more about your TI Inspire. I'm sorry, your TI 84.
Uh-huh. Yeah, I'm fine doing it by hand.
Okay. So what would you do here?
Set it equal to 0?
Okay. And that would get you the X. Well, it says to graph it by transformations. I don't know if you would want to do that or not. You don't have to do that. If you set it equal to 0, that would give you the x-intercepts, but you don't have to do that.
Okay.
If you recognize this as being in the form of a times x minus h squared plus k, does that sound familiar at all?
Yes.
Okay, well, that means that hk is the vertex.
Okay.
Okay. So all we really need is the vertex and one other point. We're going to get it pretty easily. So do you see how this is minus h?
Yeah.
So since it's minus h, that means it's the opposite. The h, the value of h is the opposite of the sign there. Okay. So the vertex is a -5, and the k
Negative
is just the
2.
same, -2.
Okay.
Okay. So we're good there. -5, 1, 2, -2. So that's the vertex, right?
Mhm.
Which means axis of symmetry, yes.
Yes.
Okay, so now all we need now is one other point. Um, Usually I would say, is he going to give you a graph like that, like a scale, or do you have to just like sketch your own?
He'll give it to you.
Okay. And we'll have numbers on it already?
I believe so, yeah.
Okay. So, um, all you need is one other point. Okay. And
Hmm.
normally I would say plug in zero, but if you plug in zero, it's going to be 5 squared times -4 minus 2. It's going to be a giant negative number. Okay.
Hmm.
So what you want to do is plug in the number either to the right or to the left of the axis of symmetry on the x-axis. Okay.
Okay.
So I just totally screwed that up because it's at -5, -2, and I did -6.
Oh, I did not even realize.
Yeah, I blame you for not realizing it. So, I mean, come on now. So, -2. Okay. So, and you don't have to draw this. I just
Uh-huh.
did it because of what we are going to do. So, I would choose -4.
Okay.
So if you that what we're doing is just finding one other point, right? So it's sort of
Hmm.
like, okay, I'm going to plug in -4 for x and see what I get for y. So it would be -4 times -4 plus 5 squared minus 2, right?
Hmm.
Which you can crank it in your calculator, which becomes -4 times 1 minus 2, which is -6. Okay, so we get the point
Okay.
-4, -6. Whoop. So that's down to here, right?
Yes.
And the reason that we only need one is once we have one that's not the vertex, we have one on the other side of the axis of symmetry, exactly the same distance away because it's perpendicular.
Symmetric.
Yep. And then we're good. How's that?
Cool.
I know, math is so cool. Okay. Does he do this where he gives you choices too, like this one?
Sometimes, but it's mainly fill in the blank. But yeah, there has been like one or two of these on the test I've taken.
Okay, this one is a little easier. Like what he's trying to get you to learn or is like to take a parent function, the square root of x, and then move it according
Hmm.
to what happens to it. Do you remember doing that?
Yes, I believe so.
Um,
I did not memorize all of them though. I will be honest with that.
oh, I put it in your calculator. Graph it in your
Like,
calculator.
okay.
So you're going to hit the y equals button,
Hmm.
and then do you see your square root button above the square
Yes.
button?
Yes.
Okay, so I think it's y1 or something. I don't know, equals, and then do square root, and then remember where your x button is? It's that one that has,
Yes.
yeah, okay, -5, and then
Yes.
right
+5.
arrow out from under the square root to put the +5,
Hmm.
and then hit graph. And does a graph show up?
No, it says error window range. It says one quit and it says check values in window. Example, X max
All right,
is less than X minimum.
yeah, we're gonna fix that right now. I know this happened yesterday, and now I know what happened. TI 84. Um,
Will it change the settings with the other answers I get though? Like with
nope, not at
the
all. Not at
okay.
all. Okay. Is there a zoom? Can you hit escape or something to get out of that?
To get out of like the zoom.
Well, no, go ahead. No, go ahead and hit zoom.
Oh, on my calculator. Duh.
Yeah.
Okay.
And does a window pop up with choices?
Yes.
Okay. Hit six and then enter.
Which is Z standard.
Yep.
Okay.
Does the graph show up now?
Um, let's enter. It does, but hold on. This is. It came up and then it went away, and now it's saying invalid dimension, and it says to check the one is less than dim list to set plots off second stat plot.
It must be in a different mode. Let's forget about it.
Okay.
All right. Um, okay. So then you got a couple of choices. You can either recall that the square root of x curve looks like this.
Mm-hmm.
Okay. And if you forget that, you can put in points for x and y.
Okay.
Okay. Um, and then we can move that. But I think what I'm going to suggest is we just put in points for the original function because it
Okay.
because there's another step after this which you probably don't remember about transforming functions. So we might as well just put in points for the original function,
Okay.
which is this one. Okay, so do you agree that we cannot find the square root of a negative number?
Yes.
So if that's true, what is the least value of y or x that we can choose if we can't get a negative under the square root?
5.
Good. So if we plug in 5, what do we get?
Um, well, it'd be a 0 under the square root, right? So would it
Good.
just cancel out
Yep. And then 0 plus 5 is
as 5?
good. Excellent. Okay. Um,
Mm-hmm.
then since you have a calculator, you don't have to worry about having a perfect square under there, right?
Okay.
Okay, so but 6 is going to give you a perfect square because 6 minus 5 is 1, right?
Mm-hmm.
So if you plug in 6, what do you get?
Um, 6?
Good.
No. Um, is it 6?
Yeah, because the square root of 1 is 1, plus 5
Right.
is 6. So this is
Okay, I
just
was right.
fabulous news. So now if you're looking, you're looking at which graph has the points 5, 5, and 6, 6 on it, and that's D.
Okay.
But if you don't have that, then you would just plug in more, like do 7.
Okay, good to know.
Um, and that's going to be a decimal, but who cares? And we get 6.4.
Okay.
And then you might want to go bigger, like 9 is going to work out nice. And it's going to be 9. No, it's going to be 7. And then you can just plot those points, right?
Okay.
And unless if there is a square root or there's variables, it's always going to be a curve. So you don't want to like make a straight line. So it's good. You'll see it's going to look like this one, and if you're ever unsure, just keep plotting points until you're
Okay.
confident in the shape. Okay?
All right.
Okay. Okay, so do you remember how with the parabola we had x minus h plus k?
Yes.
Okay, the same is true for absolute value functions. It's a times absolute value of x minus h plus k.
Mm-hmm.
It's not the vertex, but the absolute value function, it comes to a point, and it's either like that or it's like that.
Okay.
Okay. So you don't necessarily have to know this, but you have to find the point in order to get credit for the graph. And so the point here would be at positive 1, 7. Is that okay?
Yes.
Okay. Since it's negative, you know it's going down. And if you remember its absolute value, you really only need, once you find the point, you only need one other point.
Okay.
Okay. So just sort of like what we did before. If we picked one, it would be negative 0 plus 1 is 7, whatever. Okay. So we're going to pick something that is, you want to pick something very close to the right or left of 1. So,
Like two?
sure. So if you plugged in 2, what would we end up with?
Um, -1 plus 7?
Good.
Or would it just be 1?
No, it's negative 1
Oh,
because
right, right, right.
it's outside.
Okay, I was right. Cool.
Yeah. So that's 6, right?
Mm-hmm.
And so the absolute value graph is also perfectly symmetrical. It's a legit V, right? So once I have two, 6,
Mm-hmm.
right? And this is and I know this is the vertex or the point of the graph, then it's exactly the same distance on the other side. So it would be at 0, 6. And then you can just go whoop, whoop, just like that.
All
Or
right.
you, if you forget that and you can't find where the point is, you just keep doing graph or you plug in x's until you find it, right?
Okay. Right.
Okay. And so you might, if it keeps like going down, 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 if it's if it's going to open up or open down because of what's out in front of here, right? So
Mm-hmm.
if you, I don't know, let's say that you start plotting X's and Y's, and you know it's a happy one, right? And you just
Mm-hmm.
kept getting Y's that keep going up, right? Then
Mm-hmm.
you need to start choosing values of X going the other way.
Okay.
Because if they keep going up, you're not getting closer to the point, right? You got to go this way to get to the
I
point.
gotcha.
Does that make sense?
Yes.
Okay. Well, he's just not messing around with these, is he? Oh, I really wish we could get your calculator figured out. Yeah, you don't have another one, do you?
No, but it's all good. I can do these by hand. I feel pretty confident about it.
Okay. Um, I am going to send you uh, parent function shapes. Actually, I'll just put them in the notes. So this is y equals x squared, the cubic function, the absolute value function. I don't think you need these, but so I'm sure that the questions could come from linear, quadratic, cubic, absolute value, and square root. So that shows you the basic shapes. If it's, if you can memorize those, it helps because at least you know what shape your graph should be, right?
Mm-hmm.
I,
Okay.
you might have, I'm not sure, you're not going to have logarithmic. Have you had logarithms?
Yeah, I don't like them.
I would imagine it's going to come from one of these. Let's see what the review
Yeah.
puts. Okay. So if we know that, then we know that it's going to be, it's going to look something like that. Since it's a negative out in front, it's going to go like this.
Okay.
It's going to flip, but you know the general shape. Okay.
Okay.
So again, there's no top or bottom to this one. So I think we have to um, plug points, right? And if you're not sure, it's always kind of safe to do something like this. Okay.
Mm-hmm.
Um, so, and then you can see if things get ridiculous, like at -2 minus 4 is -6 cubed. That's huge, especially if it has a scale from 0 to 10.
Mm-hmm.
So you don't even have to worry about it, really. I wouldn't even put it in there. I guess if you put it in there, you could, and then at least you know it's coming from way up high, right?
Right.
So negative, comma, or not negative, comma, parentheses, -2 minus 4. Are you fine plugging stuff in?
Yeah.
Yeah, so it's 216. If we plug in -1, we get 125. Okay, great. Whoops. Um, if we plug in 0, we're going to get -64. We plug in 1. Oh no, we get +64. Yeah, we get +64. Sorry. So you can see it's coming down. So that means you're going to have to keep, you know what I mean? You got to keep going until you're on your scale.
Okay.
Maybe you can see what's going to happen, you know what I mean?
Mm-hmm.
Um, so 1 is going to be 27. Then we start to get reasonable. 2, oh no, it's not going to be 27 because that was 0 because we still have to subtract. Oh no, it is 27. Okay. 2 is going to be 8, finally, right?
Right.
So we get 2, 8.
And do you plug these numbers into both equations or just one?
Oh no, I'm just this one because they're asking you to
Okay.
graph this one. What they're trying to get you to do is to take the parent function, flip it around, and move it. But um, I'm not sure if you don't remember it, it's a lot to remember.
Mm-hmm.
So that's why I'm suggesting just plotting points.
Okay, I see.
You plug in 3, um, you get 1. So we're getting somewhere. 3, 1. Plug in 4. 4 minus 4 is 0. You get 0. Plug in 5. You get -1, and then you start getting some symmetry there.
Okay.
If you know the curve, you can see, oh, okay, it's going to start going like this, like that.
I see. Okay.
Okay.
I said okay.
All right, cool. How you feeling overall about this thing?
A little nervous, but also pretty confident that I'll do well. I'm sitting at a C, and the final test also replaces your lowest test score. So
What
I think it'll bump me up to at least a very high C or B if I do well.
what if you don't do well? Does it
It, if as long as it's better than a test that I previously took, he'll replace that score.
what if it's not better than a previous test? What if it's your
Then
low?
he won't replace it.
Oh, okay. Well, it's going to be better. How about that?
Yes, yes. Oh, for sure.
Okay. So, what's your lowest test score?
I think it was like a 65.
Okay. You're not going to do, I mean, you're not going to fail the class.
No, no.
Okay. So, F plus G. Well, we just add them. So we combine like terms, right?
Hmm.
With the minus, you just got to be careful because you have to make sure that you're subtracting the entire part of G. So I like to put parentheses around there.
Okay.
So F times G is no fun. So, and that said, determine the domain. As long as we're not taking the square root or we're not dividing, it's negative infinity to infinity.
Okay.
So here, this is where you have to take the everything in the first times everything in the second.
Hmm.
See what I'm doing?
You lost me on the second step of that.
The 2 times 4x
No,
when I
where did the
started.
x squared go? Um, so you have 2x
So 2
squared.
times x squared,
Oh,
then
okay.
2 times 4x, then 2 times negative 12.
Oh, okay. So you just foiled. Okay.
Yeah, and then I have to do the same thing with negative x squared times everything in here.
Okay. Okay.
And the good news is for f over g, okay, and again, this is negative infinity to infinity because we're not
Mm-hmm.
dividing, we're not taking the square root. With square root, you can't take the square root of a negative number, right?
Right.
And dividing, we can't divide by zero. Or like when we have a fraction, the denominator can't be zero.
Right.
Here, we're going to write a fraction,
Mm-hmm.
and then we're going to factor.
Fun. I hate factoring.
Except that's not going to work. Oh. So we're going to have to do, do you remember doing long division with this nonsense?
Kind of. I think I remember him talking about it.
The reason is we can't, this is not factorable
Okay.
because that's not a perfect square. If it was, it would be factorable. So the long division would be the top divided by the bottom. So let's see if this looks familiar to you. And we have to put them in descending order, like negative x squared. Do you remember this at all?
Yep.
Okay. Okay. And then we have to put in a guy for every, like we have to put in 0x to the first power because there's not an x to the first power and then the constant, right?
Mm-hmm.
Okay. So then, I'm so dumb. That goes underneath, not up here. Sorry.
No
Up here is
worries.
the quotient. So negative x squared plus 0x plus 2. Okay. And then what we do is we think to ourselves, what times x squared would be negative x squared?
-1.
Negative 1. Good. So it'd be negative 1 times x squared and is negative x squared. Then negative 1 times negative 4x is negative 4x. And then negative 1 times negative 12 is positive 12. Is that okay?
Yes.
Okay. And then we have to take top minus the bottom.
Okay.
So negative x squared minus a negative x squared, that's always going to be 0. That's always going to cancel out. That's the whole point of it. Okay.
Mm-hmm.
0 minus a negative 4x turns into plus 4x.
Yes.
And then 2 minus 12
Which
is
is 10,
negative 10.
-10.
Okay. We're actually done with this because there is nothing times x squared that gives us 4x, right?
Right.
So that's our remainder. Okay. So
Mm-hmm.
the answer is negative 1 plus the remainder, 4x minus 10, over uh, the divisor over this thing.
Okay.
So now for the domain, we have to figure out what's not allowed.
Mm-hmm.
And whenever you have a fraction, what's not allowed is whatever values of x would make it equal to 0. So you have to solve. You have to solve that, okay?
Mm-hmm.
So it would be, let's see, x plus 6. Do you remember how to factor like this?
Yes.
I need factors of negative 12 that combine to give me positive 4.
Mm-hmm.
And really for this, we can say not equal because we don't want them to equal this.
Okay.
And I don't know if he would accept that as your domain. Generally, it's accepted if we just say that X, like the domain, X cannot equal negative 6 and X cannot equal 2. It's generally accepted that the rest is all the real numbers.
Okay.
Now, if he didn't like that, you would have to go left to right, like negative 6 to, I'm sorry, negative infinity to negative 6.
And then union -6 to 2 union. Okay.
There you go. How's that?
Perfect.
Okay. I like to write these. This is f of g of x, meaning you plug g into x.
Okay.
Okay. And the way I like to do it is I say, all right, whatever's on the outside, I rewrite it, unless you get really good at it, which maybe you are. Okay. And I'm
Mm-hmm.
finding f of g of x, right?
Right.
Which means wherever I see x, I replace it with g of x.
Okay.
And g of x is equal to 2x plus 4, isn't it?
Mm-hmm.
Plus the 2, and then you're done. 2x plus 6.
Okay, I got it. How would you do it for with the one?
Okay. Well, you just did, there's two ways to do it. And I'm gonna show you what, I mean, if you've already done f of g of x
Mm-hmm.
and you have the expression, right? This is f of g of x, right?
Right.
Well, they're asking for f of g of 1, meaning wherever you see an x, you replace it with 1.
Oh, okay, okay.
Now, if you didn't do this, you could do it with x, or, recognize that it's f of g of 1, right?
Mm-hmm.
Well, you can work from the inside out. G of 1, wouldn't that equal 2 times 1 plus 4,
Yes.
which is 6?
Oh, okay, okay.
Okay, so then that means that this equals, if g of 1 is 6, this becomes f of 6, right?
Mm-hmm.
And since f of x is 6x plus 2, this becomes 6 plus 2.
Oh,
All good?
perfect.
All right. Ooh, snap. Circles. So I think we did complete the square, didn't we, before?
Yes. And then I think you showed me how to do it in the calculator. Uh,
We can't,
yeah,
like, because there's an X and a Y
right.
in this.
So you have to do this one by hand.
Right. So in order to do it, you have to do both the X's and the Y's.
Okay.
Okay, so I'm going to leave a space to add something to the x.
Hmm.
I'm getting the x's together and then the y's. And I'm going to add something to the y and I'm going to move that 26 over.
Okay.
Okay.
Hmm.
Okay, then off to the side, I'm going to do my little work, or I can do it in my head. So I take half of the coefficient of the x term, and then I square it.
Okay.
And that's what I add. And what I add to one
Okay.
side, I have to add to the other.
Right.
Okay, and then I do the same thing for the y. I'm going to add 9 to both sides.
Okay.
Okay, and so then the whole reason we do this, if you remember, we can then factor this into x minus 1 squared, which is whatever this guy is,
Hmm.
plus y minus 3 squared
Okay.
equals 36. Okay.
Hmm.
And so the general equation for a circle is x minus h squared plus y minus k squared equals the radius squared.
Okay.
Meaning the center would be, remember it's minus, so it's opposite of whatever the sign is there.
Hmm.
So it would be positive 1, positive 3. And so r squared equals 36. R is the radius, so we want r, not r squared. So the radius would be the square root of 36, which is 6.
Okay.
Okay?
All right.
So we didn't get to the last two. If you'd like, a little bit later, I can work them out step by step and send them with your notes later. Does that sound good?
Perfect. Thank you so much.
All right. Let me know how you think you did, or when do you know your score?
Hopefully later that day.
Oh, okay. All right.
Yes, we shall see.
Well, go in with confidence. I think you're going to do great.
Thank you so much. I appreciate it.
Yep. Have a good evening.
You too. Bye.
Why is it recording?
Um, because my previous student was recording, number one. Number two, I have you canceled for today and for Thursday.
Oh, okay. I wasn't. Oh, my Wi-Fi crashed out.
No, you're there. So, bye.
Hello?
Hi. Bye.
Sorry, my Wi-Fi crashed out. I didn't hear a word you said, but I didn't remember that my mom canceled. Sorry.
That's okay. Bye.
Bye.
Hey, Charlie.
Hey, can you hear me?
Yep.
Okay.
I'm recording for the previous student, so I have to end it to stop the recording and then start over. Okay?
Okay.
All right. So you'll have to rejoin, I think.
Okay.